Also start measure theory, and obviously measurable set with with respect to some outer measure. Okay, we start about measurable set. Measurable set with respect to outer measure. With respect to outer measure, mu star. Okay, I start about these things. When a set be measurable set, okay, we known about in previous class definition of outer measure, which measure is satisfied some property mu phi equal to 0 and mu be monotone and mu is countably sub-additive. Okay, then we called this mu is outer measure. Okay, and obviously in previous class we also discussed so many things about measure, but today we also discuss measurable set. Which set is called measurable set? We just written this now. Let mu star be an outer measure. Let mu star be an outer measure. Okay, outer measure on px, power set of x we construct. Okay, then what happened? Then we talk about then a set E subset of X. This E be measurable set. When we talk about this set E subset of X be measurable set with respect to mu star. With respect to mu star, that means this outer measure. When if we known about that mu star E equal to mu star E intersection A and plus mu star E intersection A complement. Okay, where A is what? A is for a subset of X. Any subset of X, A. Okay, then oh sorry, or do it, that means oh no, or done it wrong. Here this one E complement. Okay, and here mu star A. Okay, that means E is measurable. E is measurable with respect to E is measurable with respect to mu star when mu star A equal to mu star E intersection A and mu star E intersection E complement intersection A. Okay, a set E is measurable set with respect to mu star if this one happen. That means mu star A equal to mu star E intersection A and mu star A E complement intersection A for all A subset of X. Okay, if this one happen, then we call this set E be measurable set. Okay, now we're going to, that means so phi is mu star measurable. We also prove this one. Where is that portion and going to discuss about that. So when one set E is measurable, if some subset A subset of X and mu star A equal to mu star A intersection E and mu star A intersection E complement, addition of those two equal to mu star A, then this one E is measurable with respect to mu star. Now talk about phi is mu star measurable. Okay, how this was happen? Phi is mu star measurable. That means what we have to prove? First basic need. If we are to prove, that means prove something, then basic need is that what we have to prove. That means to prove what? Okay, first we decide these things. So phi star is mu star measurable. This means we have to prove that mu star A equal to mu star A intersection phi plus mu star A intersection phi complement. Okay, for a subset of X. Okay, so we have to prove this one. This one we have to prove. Now we are obviously doing next step. Next step is so easy. Okay, what is this? Mu star A equal to what? Mu star A intersects not this one in this way or not do this. Okay, where is that portion? Okay, left hand side equal to mu star A. Okay, and right hand side equal to, consider this one. Okay, then this one equal to what? Mu star A intersection phi. This one equal to what? Mu star A intersection x. This one equal to mu star phi. This one equal to mu star A. This one equal to, obviously we known about that. This one is the definition from definition of outer measure. Okay, from definition of outer measure we're getting this. Okay, 0 and mu star A, then obviously we're getting this one is mu star A. So left hand side equal to right hand side. That means we prove this. What we needed, we proved that one. So what we get? We get first is mu star measurable. Too easy problem. Obviously this one is understanding. That means all are understand this problem. But what technique you use here? Obviously any mathematical proof, any mathematical problem, if you handle this problem, how? First we have to need what we do. Okay, that things we first considered or evaluate, or we obviously find this one. Okay, first we find what you have proved or what we have do, how we proceed. Then we construct some basic tools about. Then what tools is given. Okay, and how much, that means which basic definitions or basic theorems are applied in this. That means we prove in proof procedure. This one is needed. Okay, then mathematics is easy procedure. That means easy things, not a hard one. Okay, too easy for all if you understand this, and obviously if you develop step by step wise, and something if you remind it. I'm not remind more and obviously I'm not think about more, but if you think about more and remind more, then your knowledge power is more, and obviously you do it quickly. Okay, so today I address this portion and going to another definition of another problem, which problem is xb mu star measurable. We also prove this. Okay, how we prove it? We write here first what we prove xb mu star measurable. Okay, how we prove this one, how we prove this problem. First what we need, then what we need to prove, we have to write this. To prove what we prove here mu star, oh sorry, not this one is by mistake. Mu star A equal to mu star A intersection x plus mu star A intersection x complement. You have to prove this for all a subset of x. Okay, I have to prove this, then this. That means then our required result is done. That means I have to prove xp mu star measurable. This one is first needed. That means first we evaluate this one, then next thing is too easy. What do? We do left hand side equal to mu star A remains same for a subset of x. Okay, then what? Right hand side equal to what? Here we write mu star A intersection x plus mu star A intersection x complement equal to what? Equal to mu star A intersection x equal to mu star A equal to A intersection x complement equal to phi. Then mu star A plus mu star phi, and mu star phi equal to what? Mu star phi equal to 0 by definition. Then what we get? This one equal to mu star A. So same thing, left hand side equal to right hand side, and proof now. So we get this one. So xb mu star measurable. Not a problem at all. I understand about that. I think I understand this. Okay, here we write this one by definition of outer measure. Okay, any problem at all? Any problem here? Not a problem at all. Now where is this portion and going to forward this further discussion of this portion. So what we discuss today, we discuss here one theorem. Okay, one theorem or easy theorem we also discuss now today. Oh, obviously here we're getting some observation, then we proceed to theorem. Observation is what? Observation is that so easy observation or write in that means if E be measurable with respect to mu star, E be measurable with respect to mu star, then E complement be measurable with respect to mu star. Okay, so this one is too easy. We write it in this way: if mu star A equal to mu star A intersection E plus mu star A intersection E complement A subset of X, then what happened? Mu star A equal to obviously mu star A intersection E complement plus mu star A intersection E complement whole complement. Okay, for A subset of X. Because why this one is happened, we know about that E complement equal to E. Okay, so not a problem at all. This one and this one is same. If this one happened, then this one must happen. So if E be measurable, then E complement be measurable with respect to mu star. Okay, understand or not? Not a problem at all. Too easy. Okay, writing is too bad today. Okay, so this one is obviously that means happened. Now where is that portion and going to further discussion of that. So what we discuss today, we discuss this portion. Oh, one important proposition about that. This proposition is if you want the A to be most measurable set, and then you want union A to be most measurable. Okay, what we have to prove and what is given, this one is needed. Okay, so then we'll do it clearly and easily. How this one? What have to prove? To prove what? Prove in this way: mu star A equal to mu star A intersection U1 union A2 plus mu star A intersection U1 union A2 complement. Okay, for all A subset of X. And what is given? Given that U1 and U2 be measurable, U1 and U2 be mu star measurable. That means what happened? Mu star A equal to mu star A intersection U1 plus mu star A intersection U1 complement for all A subset of X, and mu star A equal to mu star A intersection E2 plus mu star A intersection E2 complement for all A subset of X. Okay, this one is given and we have to prove this one. So how we proceed? Okay, how we proceed? If here A, not the arm would take a mistake. If here A, B, C, D, E, F, G, H, you do anything, not just A here. Okay, if you construct C, then not a problem here. If you construct T, then not a problem here. Okay, so this one is given. Then we have to prove that, and we also further proceed. We erase that portion and also proceed to prove this. How we going to prove? Here we write in this way: A intersection E1 union E2, okay, equal to what? A intersection E1 union A intersection E2. So simply, but we write in this next line: A intersection E1 A intersection E2 intersection E1 complement. Okay, understand? Not a problem at all. Then what happened? Then in next, that means next line, what we get? Mu star A intersection E1 union E2 less than equal to mu star A intersection E1 plus mu star A intersection E2 intersection E1 complement. Okay, because these two are where a subset of A, these two are obviously disjoint. Okay, then obviously disjoint, and obviously we apply here, not only this one is needed, we apply here mu star is countably subadditive. Okay, next we're going to this portion. Here we write mu star A intersection E1 union E2 plus mu star A intersection E1 union E2 complement equal to what? Equal to mu star A intersection E1 union E2 plus, oh sorry, here mu star A intersection E1 complement intersection E2 complement. Okay, understand or not? Understand, I think. Then what happened? Then less than equal to. Okay, then less than equal to, we also getting from what? Getting from this. Okay, this what we get? We get this one less than equal to mu star A and mu star A intersection E1 plus mu star A intersection E2 intersection E1 complement plus mu star A intersection E1 complement intersection E2 complement. Okay, sorry, here with any problem? No, not a problem at all. We write this one. Okay, then what happened? Then so simply we write it in this way: equal to what? Mu star A intersection E1. Here A intersection E1 complement same, just E2 complement as change. So we write here A intersection E1 complement. Not a problem at all, because E2 be measurable. So mu star A intersection E1 complement. If we write another, that means if we write another line, this one is beta. Okay, if we write another line, then this one is beta. We write in this way: A intersection E1 complement intersection E2 complement. Okay, then we erase our portion and going to forward discussion of that. So what we get? We get so simple way: this one equal to mu star A intersection E1 plus mu star A intersection E1 complement. Why? Because E2 is measurable. Now also going to write this one, mu star A. Then what? Why? Because E1 is measurable. So what we get? We get mu star A intersection E1 union E2 plus mu star A intersection E1 union E2 complement equal to what? We get less than equal to mu star A. Okay, yes or no? Yes. then obviously we're not going to prove of this portion, but just one side we also evaluate this. So we mark it number one. Okay, we mark it number one. Then what, where we going? We're going in this style. A equal to A intersection U1 union E2. Here union A intersection U1 union E2 complement. Yes or no? Yes. This one is some important property of set theory. Okay. So or do it in this way, or also do it fascinating way and write this one. Okay. What? That means mathematics as an important topic. Mathematics is the mother of science. Mathematics is going to logistic way. Obviously from lower level, class 1 to upper level. That means postdoc, some research and doing new invention. Every level have some stepwise development. That means if you know basic things, step by step you develop, then one small 5-year child also understand this and doing this process, this math. Okay, because if we know, if he or she know this procedure, if he or she obviously develop in this procedure, then obviously 5-year child also do it. Okay, because mathematics is just based on understand power, and obviously growth from stepwise. So if you develop stepwise, then no one can stop you. Okay, you're getting knowledge, obviously done everything, not a problem at all, and Noha is your stuff. Okay, any problem you have to find, then obviously you not stop there. If basic tools are obviously in your knowledge, but obviously lack of more knowledge, I spend more times but not getting this result. That means this procedure are not known from any professors or any masters or any others. Okay, so I'm obviously like more than spend more time with this mathematics, but not getting one appropriate place of positions how my thinking power is used. But I'm positive with. Okay, I'm with this journey, not loved this journey. So in this way also develop mathematics. This one we mark this 2. Now from 1 and 2 what we get? Now from 1 and 2 we get what? Mu star A equal to mu star A intersection E1 union E2 plus mu star A intersection E1 complement intersection or sorry E1 union E2 complement. Okay, so our necessity is completed. That means we prove this portion E1 union E2 be measurable by this. Okay, since A is arbitrary, if you write more, because some ones are needed more writing. So if you know, if you need more writing, then if you write here, since A is arbitrary and a subset of X, and this property satisfies mu star A equal to mu star A intersection E1 union E2 plus mu star A intersection E1 union E2 complement for all a subset of X. Sorry, if you not write this one, S1 arbitrary. So U1 union E2 be mu star measurable. If you write more, then this one is right, then this one is completed. Okay, but understanding level is done here. And if you dominated and fascinated and obviously writing style is needed, then this one you write, then this one is completed. Okay, I think I discussed today just small portion, measurable definition of measurable set, and two important that means example phi is mu star measurable, x is mu star measurable, and again one observation, if E is mu star measurable then A complement is mu star measurable. And then obviously we discuss about that if E and E1 and E2 is mu star measurable, then E1 and E1 union E2 is mu star measurable. Today I stop here.